So, we have many processes to achieve this transformation. Let's make some example. For instance, we have plants that contains a great amount of fat, for example, sunflower, rapeseed. This feedstock is particularly suitable for the synthesis of fuels that can substitute diesel. A very common process is called transesterification, and the product is normally defined biodiesel. Chemically, this has a composition quite close to the fossil-derived diesel, but the supply chain is based on a renewable material and a chemical process that is different from the distillation and raffination of fossil diesel. If the biomass available is different, for example, we have starch of or plants rich in sugar, we may use another process that will yield a different product. If we use sugar and starch as reactants for a process made of this step, hydrolysis, fermentation, and distillation, we can get the molecule of ethanol. Actually, this intermediate step is really similar to the one of wine production, so we can turn sugar matter into an alcohol, a very easy alcohol with just 2 carbon atoms that can be a very good substitute for gasoline. So this ethanol again is bioethanol because it comes from a biomass feedstock. We may use also lignocellulosic biomass, for instance wood residues, wood chips or pellets, and this case is very interesting when it comes to second generation biomass, because we may have a lot of wood waste to turn into something with a energy value. So lignocellulosic biomass may undergo several processes, and this is the first. So if we take it and pre-treat it, like grind the wood pieces into smaller particles and so on, we may have something very similar to sugar and starch and use again the process of hydrolysis, fermentation, and distillation to get again bioethanol. Otherwise, we may use another process, a thermochemical one called gasification. So again, we start from lignocellulosic matter. There is a pretreatment aimed at reducing the size of wood particle, and then we perform a partial oxidation of wood that release fuel gas with a good energy content. In the technical practice, the gas product is called producer gas. This is a mixture of hydrogen, carbon monoxide, and other gas components that do not have energy content like carbon dioxide and nitrogen. Then another thermochemical process that is used for wood conversion is pyrolysis and hydrogenation. Again, from this process we have a gaseous product similar to producer gas but with a slightly different composition, but also a big liquid residue. So from pyrolysis we can get also a liquid blend of hydrocarbon that usually is called bio-oil that can be used for many other energy purposes. Just a simple application of lignocellulosic biomass is the production of pellet, and this can be used for heating application, and in some case also for small power generation based on external combustion of pellet. Finally, there is another category that is wet biomass. So for example, all the animal waste we can collect in farms. Starch, vegetable oil, and lignocellulosic biomass are almost dry matter. Animal waste contains a lot of water, and this makes all the other process not suitable for this feedstock. So for that, the most common application is anaerobic digestion. We have the decomposition of the organic matter we have, and the anaerobic process. So there are some bacteria that transform sugar and organic molecules into very small molecules like methane and carbon monoxide. This gas mixture has a very good energy content, and it is called biogas. So we have a wide range of possible biofuels that we can obtain from biomass: hydrocarbon, bio-oil, ethanol, producer gas, and biomass. All of them are good to feed fuel cell. They can be turned to hydrogen before feeding the fuel cell, and this need will be set by the kind of fuel cell technology that we want to implement. To know more about the integration of biofuels with fuel cell, let's go to the next presentation. Thank you.